right, today we're going to talk about the product rule for finding the derivative and the quotient rule. So the product rule is a little bit easier to remember. So if we want to find the derivative of a product, all right, the rule says that you are going to leave the first part alone, the first factor alone. So just leave f of x like it is, multiply it by the derivative of g of x, and then plus, and then do the opposite. Leave g of x like it is and multiply it by the derivative of f of x. Now, it's a little easier to remember, and because it only involves multiplication and division, if you kind of get the order mixed up, it's fine, because you're multiplying and adding, and so it doesn't really matter on the order. The quotient rule is just the opposite. Order absolutely matters. So if we want to find the derivative of a quotient, all right, this rule is a kind of a long fraction, and I always tend to embarrass myself when I teach this, and it's okay, because you guys can laugh at me as long as you remember it, but I try to say it like a football coach calling in a play. So it's kind of weird and goofy, but hopefully you'll remember it or hear me being silly in your head. So when I say these weird things, when I say high, I mean the numerator, and when I say low, I mean the denominator, and d is going to be derivative, all right? So it's low, d high, minus high, d low, over low squared. All right, I'm not going to say it again. So if you need to hear it again, you just have to rewind the video. All right, so that is how you do the quotient rule. So there's multiplication, subtraction, and division, so the order definitely matters. All right, and then I put a little note in there that sometimes it's easier to simplify the original function first and not worry about using these rules, and so we'll definitely do a couple of those to help you recognize it. Now, one thing my students tend to do throughout the years is kind of mess up on when you use the product rule and when you just do it like we've been doing it. So this first one over here, y equals 3 sine of x, we've been doing problems like that without the product rule. So this is the product of 3 and sine of x, but if this is just a constant, we're going to use the product of a constant rule. We don't have to worry about the product rule, because if that in the front, which you're multiplying by, doesn't have an x, do not use the product rule. So if we want to find the derivative of y, is going to be 3 times the derivative of sine of x, and the derivative of sine of x is cosine of x. All right, this other one, on the other hand, it is the product of two functions, and both of those have a variable. So we are going to use the product rule to figure this one out. So I'll just call it y prime this time. All right, so on that product rule, remember that the first one, or the first part, you leave the first function alone. So we'll say this is f of x and this is g of x. So we're going to leave f of x alone. And then we're going to multiply it by the derivative of g of x. And the derivative of sine of x is cosine of x. All right, and then plus, let's see if I can have it all. All right, then we're going to leave g of x alone. So sine of x stays like it is. And we're going to multiply it by the derivative of f. So that's going to be 6x. All right, and then I'm going to clean it up slightly. There's really not a lot we can do. I mean, if this was on free response, probably wouldn't be. But if it was, you can leave it messy. But I'm just going to go ahead and put my 6x in front of this sign, and that's it. So that's the product rule. All right, on example 1a, all of these, we're going to find the derivative of the function. I think this one is one of the ones that it might be easier if we just multiply it instead of using the product rule. Now, before we multiply it, though, I do want to rewrite the square root of t as t to the 1/2. And then I'm going to distribute that. So t to the 1/2 times 1, obviously, is t to the 1/2. T to the 1/2 times negative t. We're going to add the exponents. So we would need a common denominator. So 2 is the same as 4/2. So 4/2 plus 1/2 is 5/2. All right, and then when I go to find the derivative, I'm just going to use the good old power rule, where I will multiply by my power and then take 1 away. All right, same thing on the second one, multiply by the power, take 1 away, so take away 2/2, that would be 3/2. All right, and then today we're just going to leave our answers messy. All right, so I didn't use the product rule on that one, I just multiplied it out, and I feel like it's easier to do it that way. All right, I don't really have any other option on this one but to use the product rule because I'm multiplying 2x that has an x by cosine of x. So I'm definitely going to have to use the product rule there. And we'll talk about the other part in just a second. So there's nothing to rewrite on this one. So I can go ahead and do my product rule where I'm going to leave 2x alone, multiply by the derivative of cosine, all right, plus leave cosine of x alone, multiply by the derivative of 2x. So all of that is the derivative of 2x minus cosine of x. All right, from that, I'm going to subtract the derivative of 2 sine of x. So this is what I was talking about earlier. It is 2 times sine of x, but since 2 is a constant, I don't have to worry about the product rule. So it's 2 times the derivative of sine of x, which is cosine of x. All right, and I am going to clean this up a little bit. So I will multiply 2x times the negative and get negative 2x sine of x. All right, and then my coefficient is going to go in front of the cosine. All right, so over here, when I do 2 cosine minus 2 cosine, they subtract away. So we're just left with negative 2x sine of x. All right, so let's look at the next one. The next one is a quotient. Now on these quotients, if that denominator, like you're dividing just by x and you can divide through, then that would be a shortcut to do. But since we're dividing by x minus 3, we could do some division, but it's easier on this one just to do the quotient rule. Okay, so here we go. So the quotient rule, we do a long fraction. So we're going to do low, which is x minus 3, and multiply that by d high. So that's going to be the derivative of the numerator, so that's going to be 2x. And then the derivative of 1 is just 0. So the derivative of the numerator is just 2x. All right, minus, and then high, d low. The derivative of the denominator is just 1 over low squared. All right, now we are going to clean this up a little bit on that numerator. So I'm going to multiply it out and then subtract like terms. And that's it. All right, let's take a look at the next one. All right, so we have a quotient again. So we're going to use the quotient rule. I don't see anything we can do to simplify it in any way. So we're going to go ahead and use the rule where we have a pretty big fraction. We're going to do low, so 4 natural log of x, and then di, the derivative of sine of x, cosine of x, minus high, and then d low. So we need the derivative of 4 natural log of x. So remember, the derivative of natural log is 1 over x. So the derivative of 4 natural log is 4 over x. And then over low squared. Okay, and there's not a whole lot we can do here. You technically could leave it like that if you wanted to. This is pretty messy, and even if we do a little bit, it's still going to be messy. But this could be 4 sine of x over x. All right, but either way, it's super messy. Okay, let's look at the next one. All right, so this is what I was kind of talking about earlier. We can divide through by this x. So we can make this problem easier by rewriting it. So again, the square root of x is x to the 1/2. All right, and then I'm going to go through, since everything has an x, and divide through by x by subtracting 1 from each exponent. So it's going to be 3x plus 2x to the negative 1/2. Because 1/2 minus 1 is negative 1/2. All right, then when I go to find the derivative, I don't have a quotient anymore. I don't have a product anymore. I just have the power rule that I have to do. So the derivative of 3x is just x. And then for 2x to the negative 1/2, I'm going to use the power rule. So I'm going to multiply negative 1/2 times 2. That's going to be negative 1. And then when I subtract 1 from negative 1/2, I'm subtracting 2 halves from negative 1/2, and that's going to be negative. It's going to be negative 3 halves. And I'm okay with you guys leaving it like that today. We can leave things messy. Okay, and then this one, this is not something we've practiced a whole lot this year, and we need to get good at this. So I don't like the way this looks right now, because we have this fraction inside of a fraction. So we're going to do something so I don't have this fraction right here. So what I'm going to do is multiply the top and bottom by x. This is something that tends to come up a lot in calculus. So we're going to be really careful that we distribute it. So our numerator is now going to be 4x minus 1. And our denominator is going to be x squared plus 3x. It's definitely going to make this one easier. So you guys try this on your own. So pause the video, try this on your own. So if you were checking yours with mine, I made a little mistake. I didn't do the D low, so make sure you're better than me at this. All right, so I'm going to subtract like terms now. There it is. Okay, so that's the product rule and the quotient rule. We will use them a whole lot, and we'll add flashcards and we'll talk about them. We'll do the flashcards almost every day. Okay, so this is a pretty popular type of question on the AP exam, a lot of times on the free response parts, where they give you a table of values where you have a function, f and g, and then you have selected values of them and selected values of their derivatives. And we can use those to find different derivatives. So on A, m of x is equal to f of x times g of x, so the product of those. And so the question asks us to find m prime of 1. So what I'm going to do first is write what m prime of x is. So m prime of x is basically the product rule. So f of x times g prime of x plus g of x times f prime of x. All right, and then, so a lot of times on the free response, you will get a point just for writing that. And then your next point will come from plugging in the 1 for x. All right, and to get all these things, we just go to the table. So f of 1, you go where x is 1, the f of x function is going to be 3. All right, and then we're going to multiply that by g prime of 1. So go to the g prime column in the 1 row. That's going to be 2. All right. To that, we are going to multiply by g of 1. So go to the g row 1 column. That is negative 1. All right, and then finally, we will do f prime of 1. So f prime of 1 is going to be negative 3. All right, so that's going to be 6 plus 3 is 9. That's m prime of 1. All right, this is fun. I love doing these. All right, so let's go to the next one. All right, we are going to find h prime of 1, where h is the quotient of f and g. So I would start out, if I was you, because usually they give you a point for this, is write h prime of x using the quotient rule. So it's just straight up writing the quotient rule. So that's low d high minus high d low over low squared. All right, so you guys go to the table and plug in all those values. What we're doing, plug in the, let's do the write it using the negative 1 first, then plug in the values from the table. I'm giving you guys enough room for this. All right, so it looks like we get 15 plus 12 divided by 9. So our final answer is 3. All right, and then this last one is one that we've talked about before. We have done this with graphs. We haven't done this with tables yet. But w prime of x, since 2 and 3 are constants, we don't have to worry about the product rule. We're just going to do the constant product rule, basically. The constant is multiplied by the derivative. All right, we would go back, put 3 in. All right, f prime of 3 is negative 2. G prime of 3 is 3. So that's going to be negative 4 plus 9, which is 5. All right.